Okay, we're into the book now, and the first lesson is going to be measurements, okay? So basically it's a combination of measurements, layout, and tape corrections. The tape correction part of this particular unit is meant for organization and thought process. You probably, unless you're on a large project, the stuff I'm talking about will not really apply. It only applies when distances get larger. If you're laying out a house, you're laying out a small parking lot or something like that, what I'm talking about doesn't mean much. But I will give you an example of a friend of mine who got himself into a pretty big lawsuit because of not having the knowledge of this particular unit when he was taking dimensions for an airport. So it does have some practical application. In most of your cases, probably not a lot. But it is a good thought process and organizational effort. So we are in measurements. The chapters that you probably will focus on are chapters 4 and 13, okay, of your text. 4 has more of the background, 13 has more of the application. Okay, let's go about it. Measurements. I told you in the beginning in the first video that we are going to be using tape measures or an EDM, electronic measuring device. A lot of people will use EDM, so tape measures I still like, but the EDM is a way of getting dimensions by using a infrared ray that bounces off and measures time and changes it to distance. It's part of a total station. Unfortunately, we don't have total stations because of the cost. We need 5 sets. They're take about $250,000 to outfit what we need, and we just don't have that kind of money in order to do that. But the EDM is the electronic measuring device. The tape measure is the predecessor to that, and it's still used quite frequently in the field. So we have a tape measure. We will be using the engineer's tape. The engineer's tape comes in feet, tenths, and hundredths. We will also have an opportunity on our first lab to use the architectural tape, which is in the feet, inches, and fractions. We will not be using the metric tape. Okay, most tapes come in different materials. The one we're going to be using is metallic. It's a metal tape, okay, it's steel. It's got it stamped on, of course, and it's manufactured. It comes in a reel. We'll be using those as our tape. The metal tape then is got some properties. Heat makes it grow. Cold makes it shrink. You can actually stretch a tape a little bit. We also have some tapes out there. Maybe you've seen them in a wheel. You'll see guys wandering around with a wheel taking measurements. We also have tapes that are made out of fabric, nylon. Okay, those tapes, in my opinion, should be thrown away if you're doing precision work. If you're doing rough work just to get some quantities or information, they're fine. But if you're going to be using for laying out something that needs to be precise, I would not use those at all. We've gotten ourselves into a lawsuit when we were at Lima Refinery doing work because the field crew went out and used a nylon tape. If you pull on it, it stretches like crazy. What we ended up doing is we detailed some piping drawings. The dimensions were all wrong, and it wasn't because the guys actually physically measured them wrong. They just pulled on the tape and made the tape longer than it should have been, and every dimension was not accurate. So I would not use nylon tapes. Actually, I was administrative officer of the company at that time. We threw all of them away. Every non-metallic tape that we had in the office went into the dumpster. So be careful if you start using those tapes because you can stretch them, they can shrink, you can get yourself in a real bind real quickly. We had to pay for the installation and rework of a 20-inch diameter stainless steel pipe. Cost me about $50,000-$60,000, that little deal, because of that stupid tape that they stretched and measured the wrong measurement. So when you get out there, you try to manage risk. A tape that stretches is a risk. Get rid of it. Okay, so we got tapes we'll be using. So our measurement. Okay, we're going to talk about a couple things. One is alignment. Okay, I've got 2 points I'm measuring between. I've got a tape. The tape isn't long enough to reach both points, so I've got to move from point to point to point, and I'm going to put myself a temporary turning point in there. So I'll take and measure, and I'll put at 100 foot, I'll put a little chaining pin in the ground. The head tapesman puts it in, the rear tapesman moves up to that point, put 0 on it, another tape, 100 feet, and then another tape. And we may have 100.00 feet here, we may have 100.00 feet here, and we have 96.52 feet there. I just add them up, and the rear tapesman, as he comes along, the number of chaining pins he's got in his hand is the number of 100 feet that we've measured. Count those. In this case, he'd have 2 in his hand, so we got 200 plus the 96. So our measurement would be 296.52. What happens if the process looks like this? The rear tapesman doesn't keep the head tapesman in line with the target, and he traverses on an angle instead of a straight line. Hopefully you see that the lengths associated with that second figure are longer than the lengths associated with the first. Shortest distance between any 2 points is a straight line. So if I take this and I move it across here, the diagonal of the triangle is longer than the base of the triangle. So I got a wrong number. So alignment is big. Got to keep the person going straight. You got to be measuring between the points, not at a random fashion between the points. So we'll be dealing with alignment. That's a biggie. And that's both horizontal and vertical. I can be on a hill, measuring these 2 points. If I want the horizontal distance between them, there's the number I want. If I measure from here to here, I got a dimension that's no good. That's not the horizontal dimension. That's the sloped dimension. So I've got alignment both vertically and horizontally. So one thing I got to worry about is alignment. So alignment is big. And the rear tapesman is the person who keeps the head tapesman in a straight line. He looks from his point and makes sure they're exactly in the straight line. So alignment's one thing. We've got some problem with manufacturing. On the tape, you got a little tape in your pocket. It's got written right on it what it is, doesn't it? It says 100-foot tape. It says it's 25-foot tape. Is there any reason for you to doubt that that tape isn't 100-foot? Unfortunately, it's manufactured. Manufacturing has tolerances. Tolerances mean that it can be between numbers. So that tape could be 99.97 feet long, could be 100.03 feet long. So if we're doing something that's critical, those 300s may add up to something that's significant, may cause us problems. We may end up in a lawsuit over it. So we've got manufacturing. What we think it is, we think what it is what's written on it and what it actually is. How do people deal with that in the real world? They send it to a laboratory and they'll certify it and they'll tell you exactly how long your tape is. Okay? We don't do this for, if you're laying out a house, being off that much in the length of a house isn't going to make any difference. But there is situations out there where it's critical that you're right on. You know, I ran a co-op this summer, or talked to students on a co-op this summer, and they said their tolerances for anchor bolts is 1/8 of an inch. They're setting anchor bolts in concrete. If they're off more than 1/8 of an inch, they have a problem setting the steel. So, some places it doesn't matter, but some places it does. So we got manufacturing. Okay, we got temperature. As a tape gets hot, it grows. As a tape gets cold, it shrinks. Okay? And it has to do with the coefficient of expansion of the material. Okay? So, we got to worry about temperature. How do we know what the tape is supposed to be? Every tape is standardized for a temperature and a pull. Most of the time, its temperature is 68 degrees Fahrenheit. The lab will tell you at 68 degrees Fahrenheit, your tape is exactly this long. If it's 110 out, what happens? It grows. It's longer. If it's 0 degrees out, it gets shorter. So we've got to worry about, in most cases, this isn't a big deal, but if you're doing distance, it is a big deal. So here we got our temperature standardization is 68 degrees Fahrenheit. Okay, so if it's over 68, it grows. Under 68, it shrinks. And we've got two more to worry about. One is pull, and the other one is sag. Okay, so I got a tape. I lay it on the ground. It's supported. I grab a hold of it, and I got a grill on the one end. He's yanking the crap out of it. You can actually stretch a steel tape. You may not know it's stretching very much, but you can stretch it. Okay? So our pull, this is pull, is standardized at 10 pounds for this course. 10 pounds is a fairly decent tug. I mean, you can feel. If you have a 10 pound on the other end of it yanking, you can feel it's going to move a little bit. So we're going to do that. Okay, if it's laying on the ground, can it sag? No, it's flat, right? So the trick on pull is fully supported. Laying on a surface where it can't sag. Now, if I lift it up in the air, I'm standing here, someone's standing here, we lift the tape up. Look at the poles out along the highway. The cord, the wires going between the poles don't go straight. They have a sag in the middle. That's because of gravity. So if it's not fully supported, and this means ends only, if it's not fully supported, it's only held at the ends, it's going to sag. Now these are totally exclusive. This is a good word right here. Make sure you understand this word. Or, pull or sag. You're not going to have both of them. You're going to have one of the two. In the problem statement for the problem on the test, if you see fully supported, it's pull, no sag. If you see ends only, it's sag and no pull. So those are the things, there's several others, but those are the things we're going to worry about for this course. Okay? So you got to get yourself in a position where you understand that there's variables that can affect the dimension, and they are manufacturing, alignment, temperature, sag, or pull. So I'm going to show you a way. Your book does it different. If you elect to use the method outlined in the book, be my guest. I think it's a little harder to understand. I do it differently. Don't mix the two. You're going to do it the way I do it or the way the book does it. If you try to mix the two, you're going to get yourself in a real pickle. Okay? So I'm going to do it my way. If you like the book way after you read it better than the way I do it, it doesn't bother me a bit. Everything we do in the real world has multiple ways of attacking. If you like it better, be my guest. So right now I got manufacturing. I've got temperature. I've got pull or sag. And then I have alignment. Okay, we're going to go about doing this, and hopefully when I get done, you'll understand what I'm talking about, and then give you an example problem, and we'll call it a day. Okay, manufacturing. Here's how I do it. I make the tape corrections for these three first. Then I make the correction to my measurement or my layout dimension. And then I worry about alignment last. Okay? So we're going to do it in a couple, 3 sequential steps. Okay, let me show you what we've got here. First, I need I'm going to use letters LN. The length of the tape, one tape length, nominal. What does that mean? That means the length of the tape that you think it is, the number that's printed on the face of the tape, 100 foot. Most of our cases it's going to be 100.00. That's what you think the tape is. Leave that by itself. Come over here. L actual. And this is at 68 degrees Fahrenheit and 10 pounds of pull. So the length of the tape that's been calibrated. You send it to the lab. They put it in a room that's 68 degrees Fahrenheit, put a 10-pound pull on it, and figure out exactly how long that tape was. It could be 100, it could be 99.97, 99.96, 100.04. Okay, so that's the actual. Correction for temperature, correction for pull, or correction for sag. Okay, now if the temperature, the day you're working is 68 degrees, there is not going to be a temperature for correction.